Volcanoes are scattered across the planet. About 1,500 active volcanoes can be found across the world, though countless others are on the ocean floor. Most volcanoes, whether on land or underwater, are located where tectonic plates meet. In fact, the Ring of Fire, a path that traces the boundaries between several tectonic plates around the Pacific Ocean, contains about 75% of the planet's volcanoes. There are several types of volcanoes, primarily classified by shape and size. Major types include stratovolcanoes, which often appear as tall, steep mountains, shield volcanoes, which are flatter and dome-shaped, calderas, which are large depressions in the ground, and mid-ocean ridges, which are underwater chains of volcanic mountains. No matter their shape or size, all volcanoes emit gas and molten rock. The journey of these emissions begins deep underground in the Earth's core. The core, which can burn as hot as the surface of the sun, transfers its heat to the surrounding rocky mantle. In doing so, the heat melts some of the rock. This molten rock, or magma, is lighter than the surrounding solid rock layer, so it rises through the mantle. The magma then escapes through vents in the Earth's crust, causing volcanic eruptions. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe, particularly liquid surface water and life. According to one theory, much of Earth's water is as old as its rocks, both of which having formed during the Earth's earliest days. Because of Earth's unique distance from the Sun, the planet is able to contain water in all of its forms, liquid, ice, and gas, rather than have them permanently frozen or evaporated into space. But Earth is the only known place in the universe with liquid water on the surface, thereby having unique cascading effects on the planet. It hydrates the land, helping create nutrient-rich soil. It collects and pools to form oceans and freshwater systems. And it cycles upward to add moisture to Earth's protective atmosphere. And where there is liquid water, there is life. About 3.8 billion years ago in Earth's oceans, primitive life existed in the form of microbial organisms. They, in the ensuing billions of years, gave rise to a range of more advanced life forms that thrived in Earth's seas, lands, and skies.
Water covers 71% of the Earth's surface and is vital to our daily lives. It can also be a clean, renewable, reliable source of electricity. Hydroelectric energy comes from capturing the force of moving water that's in our Earth's rivers and oceans. We do this by using the movement of the water to spin hydraulic turbines. That generates kinetic energy, which is converted to electricity through a generator, and then sent to the power grid. Most hydropower is generated from dams built on rivers and streams, often where there's a big drop in elevation, so gravity can help us out. Dams block the water's natural flow and force it through a large pipe with the turbine and generator, before releasing it back into the stream on the other side of the dam. Today, we know that dams, most of which were built before the 1960s here in the US, can disrupt river ecosystems. There haven't been many new hydro plants built in the US in a few decades, but some existing dams are beginning to be tapped for their electricity generating potential, and existing hydro facilities are being upgraded to be less harmful to plants, fish, and wildlife. This helps us get the electricity we need while protecting the natural environment around us. Biomass, the original renewable energy. It's been part of our lives since our ancestors learned to control fire. In fact, it's made possible by the sun, whose energy is absorbed by trees and plants through photosynthesis, and then released when organic matter is burned or decomposes. First, there's plant waste. Wood scraps, sawdust, and crop waste can be collected from farms or manufacturers. The waste is burned to heat water. The hot water creates steam. The pressure of the steam spins a turbine. The turbine powers a generator. The generator creates electricity, Simple, really. Next up, animal waste, also known as the problem of cow poop. The solution? Waste from farm animals can be collected in a large tank called a digester, filled with bacteria that eats the waste and converts it to methane gas. The methane is captured and burned to heat water and create steam. Sound familiar? Second verse, same as the first. This same principle can also be used to capture methane, a potent greenhouse gas with 25 times the heat-trapping ability of carbon dioxide, from landfills. Once a section of the landfill is closed off, pipes are run from the waste to collect the gas, which can then be burned to make electricity or heat. Biomass may not be the prettiest form of renewable energy, and it needs to be used carefully and thoughtfully to protect ecosystems and prevent greenhouse gas emissions, but it can be a smart way to make use of waste. Question: what's the most abundant energy source in our solar system? Here's a hint. It's 1 million times bigger than the Earth, and without it, our planet would be a dark, cold rock floating in space. You guessed it, the incredible, brilliant sun. The Earth gets more energy from this ball of fire and gas in one day than the whole world's population uses in an entire year. Every living thing depends on the sun for its existence, from tiny microbes deep in the ocean to plants, animals, and people. Humans have been tinkering with solar energy since the dawn of time. Ancient civilizations used glass and mirrors to light fires, but it wasn't until the 1950s that technology was developed to convert the sun's energy into electricity using photovoltaic cells. Today, solar technology is more efficient and less expensive, and is used all around the globe to create electricity, heat water, cook food, and even power vehicles. So how do solar panels usually work? When the sun hits a solar panel, material inside, usually silicon, absorbs the energy. This causes the electrons in its atoms to get very excited and start dancing around. The atoms then get hot and shed the electrons, which travel out of the panel, through copper wiring, and zap! We have electricity. A control device, called an inverter, changes this electricity from direct current to the alternating current we use. The electricity then passes from breaker boxes to outlets and into electrical items, like your computer and lights. Whatever you don't use can go back into the grid to be used by someone else. So there you have it, the amazing power of the sun.